Hello, Mr. Goodenough. I am David Gutierrez from your 4th hour science class, and today I will be showing you, or explaining to you, the 3 laws of Isaac Newton. Now, Isaac Newton was an English philosopher, or actually better said, he was a scientist that discovered gravity by watching an apple fall off a tree. So, yeah. Anyways, let's get started with the 3 laws. The first law of Newton says that an object at rest will stay at rest, and an object in motion will stay in motion unless an outside force acts upon it. Now, pretty much what this means is an object, like this car, at rest will stay at rest unless an outside force, which it being my hand, acts upon it. Now, if I were not to pick this car up, or if nothing were to move this car from this position, it would stay there for eternity. This object will stay here forever. Now, the same thing goes for an object in motion. I'm saying this. If this car were to keep moving, without anything stopping it, it would keep moving forever. So the same rule sort of applies for both of the actions, and yeah. So recently I saw this video of astronauts in the International Space Station, and one of the astronauts there, he let go. He had a tool in his hand, and he let go of the tool. Now the tool, pretend my hand is not there. The tool was just floating there in gravity without nothing. It was not spinning. It was just standing there, or floating there. And I thought that was a perfect example of an object at rest. So, I mean, the object stood there, and then later on in the video, there were a few astronauts working on a project, I suppose, and one of the astronauts asked for something, and the astronaut who had it, he pushed the object towards the other astronaut. Instead of the object, just instead of falling, it just floated slowly over to the other astronaut in the same direction, which is a perfect example of an object at motion without an outside force acting upon it until it came close to the other astronaut, which he then snatched it out of the zero gravity. And yes, so that is my first definition of the first law of Newton. So yeah. The second law, moving on. The second law of Newton is the law of acceleration, I believe. And pretty much what this law says is that acceleration is made when a total of force is applied to an object with a specific mass. Now, pretty much what that means is that the force, pretty much what to cause acceleration, you have to use force, and that force has to be equal to the amount of mass that the object that you're trying to use force on has. Yeah, as it has the same amount of mass as force. Now, pretty much here, actually, let's use this here. This jet airplane. Right now, I'm not using the same amount of force it is to, or the amount of force to pull this object, or to push this object. But if I increase my force, I can push this object. And if I just increase my force a little bit more, I can just, you know, move it around. Now, pretty much, that is pretty much the example of using force. But to calculate the amount of force that is used, there is a formula which has been made, and pretty much what it is force equals mass times acceleration. Now, let's imagine this airplane weighs 100 pounds. Alright, anyways. Now, someone is trying to push this airplane. Now, to push the airplane, they'd have to to find out the force of the amount of force that is needed to push this airplane. I have to do. Let's pretend the acceleration of pushing the 100-pound airplane is 0.5. Now, if pretty much what I have to do is multiply the mass, which is 100 pounds, times the acceleration, which is 0.5, which equals 50. In this case, 50 newtons. And newtons are the unit which is used to define force. So 50 newtons will have to be used to push this 100-pound airplane. Right? So, yeah, pretty much. But eventually, the more force you use causes a more acceleration. So, I mean, that's very handy, I suppose. But yeah, moving on. Now, finally, we come to the third law. Now, the third law states that to every action there is a reaction. Now, pretty much what that means. Oh wait, I forgot. Going back to the second law. Let's go back to this object. Now, wait. No. Sorry, I'm sorry. The third law. Pretty much, the third law's definition is that to every action or force, there's an equal or opposite reaction or force again. So pretty much what that's saying is, like, for example, if you sit on a chair, the amount of force that you use to force yourself downwards onto the chair, it has to be, the chair's force has to be equal to the amount of force you use to sit yourself down. See what I'm saying? If I'm using the same amount of force to, keep this this airplane. Now, if I were to use more force on this finger, then the lesser force will go along with the objects. And same thing with shooting a gun or shooting some kind of explosive, I suppose, like a grenade launcher or a cannonball. Actually, a cannonball. Whenever the gunpowder explodes, the cannonball is being shot backwards, whenever the cannonball is shot through the air from the explosion, the cannonball is pushed backwards. But the force pushing the ball out of the force is the same as the same amount as the force pushing the ball in. So, but the effect is like less noticeable because it has a larger mass. But pretty much, yes. So that is my definition of the 3 laws of Newton. I hope you enjoyed this little excerpt sort of thing. No, I don't know why I said excerpt. This little definition video. I will see you in 4th hour Missing Enough. And thanks for watching. Bye.